A very good morning, good afternoon and good evening to all. So this is Subhendu Das, your physics mentor. Welcome to my YouTube channel. In today's class we will discuss about thermodynamic work done during isothermal process, isobaric process, isochoric and adiabatic process. So let's start the topic. So we will discuss in today's class regarding your work done during different thermodynamic processes. First is work done during isothermal process. Okay, let's start. So we know in case of an isothermal process, what is happening? Pressure and volume changes and your temperature is constant. Keep these two things in mind. So we know equation of state is, so our equation of state is PV is equals to nRT. So as PV is equal to nRT, we can write P is equals to nRT by V. We will use this equation in our further expression. So let in thermodynamic processes, that is your isothermal process, the process changes from P1 V1 to P2 V2 at constant temperature. So let's write, let the process changes from pressure P1 volume V1 to pressure P2 volume V2 at constant temperature, at a constant temperature. Okay, as it is isothermal process. So thus the small work done will be dW is equals to thermodynamic work done formula, pressure into volume PdV. So this is the small work done value. So now we can calculate the total work done. So the total work done is, previous class trick koraichi, total work done will be equal to W is equal to integration of dW, that is integration PdV. Okay, so instead of this P we can write nRT by V. So we can write integration nRT by V into dV, and the limit point, volume changes from V1 to V2. So lower limit is V1, upper limit is V2. And you see nRT is a constant because number of moles, R is gas constant and T is temperature is constant in isothermal process. So take it outside. So our expression will be nRT integration dV by V, limits point V1 to V2. And what is the integration of dV by V integration? So this is equal to nRT ln V, limit point V1 to V2. Is it clear? Then you put upper limit minus lower limit nRT ln V2 minus ln V1 bracket, and we know ln A minus ln B, that is equals to ln A by B. So according to this formula we can write it is equals to nRT ln V2 by V1. So this is the expression for our work done. Okay, and we know in case of isothermal process, for isothermal process we know, for isothermal process, in case of an isothermal process, what is its equation? PV is equals to constant. Okay, that means we can write P1 V1 is equals to P2 V2. That means V2 by V1 we can write it as P1 by P2. Okay, so instead of V2 by V1 we can write W is equal to nRT ln P1 by P2. Okay, we can write the work done formula during isothermal process like this. And also you remember, all of you remember, what is ln? Ln means log base E, and you know it well, to change the logarithmic function to the base E to log base 10 we have to multiply what? The factor is we have to multiply 2.3026. Okay, so if we will convert ln to log base 10, what will be our expression? Our expression will be, thus W is equals to, we can write 2.3026 nRT log base 10 V2 by V1. Okay, and instead of V2 by V1 we can write P1 by P2. Okay, so that means W is equal to 2.3026 nRT log base 10 P1 by P2. Okay, this is the expression for work done during isothermal process. So from the beginning, all of you start writing. Okay, you take the screenshot. So after this is our expression. Okay, I hope it is clear to all of you. Okay, next is, this is our expression. Okay, take the screenshot of this page, and last part is this one. So this is all about our work done during isothermal process. So next concept is our, come to second part, that is your work done during isobaric process. Work done during isobaric process. So all of you know what is isobaric process. In case of an isobaric process, which quantity is constant? That is your pressure is constant. In isobaric process, pressure is equals to constant. That means change in pressure is 0. Okay. So let's draw the diagram. Let's draw the PV diagram. Okay, after that you can understand. এটা इजी कॉन्सेप्ट देखो, बर्तमान ये एक्सप्रेशन गुड़ा बहुत छोट अच्छे. अच्छा, इफ प्रेशर इज कांस्टेंट दैट मीन्स द ग्राफ इज ए स्ट्रेट लाइन पैरेलल टू वॉल्यूम एक्सिस और एक्स एक्सिस बस. सो कहबार अर्थ है कौन देखो, प्रेशर कांस्टेंट देखो ये कौन देखेला, एटा करेस्पोंडिंग वॉल्यूम V1, दिस पॉइंट करेस्पोंडिंग वॉल्यूम इज V2. सपोज देखो वॉल्यूम चेंज हो ना नहीं, V1 टू V2 वॉल्यूम चेंज है बट कौटी कांस्टेंट प्रेशर. मुझे in an isobaric process pressure constant, pressure is constant. So in language what we have to write, simply we have to write as in isobaric process, pressure remains constant so its corresponding PV diagram, pressure versus volume diagram, is a straight line. Parallel to volume axis. Okay, bas. So as per the figure, let's write, let a thermodynamic process changes from volume V1 to V2, at constant pressure as shown in figure, at constant pressure. Okay, as in figure, at constant pressure P. So what is the work done value? पढ़ा is previous class third lecture रे, work done is equal to area under PV diagram. So simply we can write thus work done is equals to, work done equal to how much? Area under PV graph. Area under P versus V graph. Okay, that means we can write W is equals to, so integration dW. Okay, what is area under PV graph? Integration PdV. Small work done is PdV, total work done is integration PdV. Volume changes from V1 to V2. Finished. Then as pressure is constant, take it outside. So integration dV, volume ranging from V1 to V2. So what is the integration dV? dV integration is V. Then lower limit, upper limit V1 to V2. Then you put the value of P into upper limit minus lower limit. So V2 minus V1, that is called your area under or area below. This is area below P versus V diagram. Okay, देखो ना ग्राफ को देखो इजीली हमें जान परिया. So you see this area under this P versus V diagram. Yes, कौन हो बेटा गोटे रेक्टांगल कौन देख लो तारो ये डाला तुम्हारा P and this is your V2 minus V1. So P into V2 minus V1 our answer से वाला ना. So that is area under PV diagram. This is the answer. Okay, so take the screenshot of this language, work done during isobaric process. This is your first page, and next, okay, and last part is this one. So next come to our work done during isochoric process. Third process is our isochoric process. So next we will discuss work done during isochoric process. This is our lecture number 4. Okay, step by step we will discuss the whole chapter, so all of you listen it properly. In isochoric process, which quantity is constant? Now tell. Isochoric process, in isochoric process, volume is equals to constant. Okay, volume is constant. So as volume is constant, so what will be its PV diagram? Now see the PV diagram. Indicator diagram, it is called indicator diagram. This is P along y axis and volume along x axis. So the diagram is something like this. Volume is constant. Now see, this pressure is corresponding pressure. This is suppose P1, and let this pressure is P2, and the corresponding volume is V suppose. Okay, that means what we have to write in language. So all of you write as in isobaric process, volume remains constant. So corresponding PV diagram is a straight line parallel to pressure axis or y axis. It is a straight line which is parallel to P axis. Okay, or you may write pressure axis. So volume is constant. So here it is a very simple theory. Okay, volume is equal to constant. That volume jodi constant habo, change in volume kete, that is dv is equal to 0. So we know w is equals to integration p dv. Okay, that means it will be 0. This is your answer. So this is all about you take the screenshot. Work done during isochoric process, this one. Okay, this is all about work done during isochoric process. Always remember the answer is 0. Okay, yes. And during isobaric process, the answer is area under PV diagram. Okay, for 1 mark question, this thing will help you. Next, our last part is work done during adiabatic process. It amaro gode 3 marks best 3 marks question rasibo. Okay, all of you listen it properly. So next, fourth part is work done during adiabatic process. आम इक्वेशन जानी तो adiabatic process रो work done during adiabatic process. So what is adiabatic process? First recall this thing. What is adiabatic process? Okay, isothermal is the temperature constant, isochoric रे volume constant, isobaric pressure constant. सेमती adiabatic process रे कौन constant को? We know in an adiabatic process no heat will be supplied to the system. No heat will be supplied to system, and no heat can be removed from the system. No heat can be removed from the system. Okay, bas. So now start the derivation part. So we know equation of state for adiabatic process. We know equation of state for adiabatic process is what is that? P v to the power gamma is equals to constant. P v to the power gamma is equal to constant. Let it be K. Okay. So what is gamma? Gamma is equals to Cp by Cv. So what is Cp? Cp is equal to, always remember, Cp is equal to molar specific heat at constant pressure. Okay. And what is Cv? Cv is the molar specific heat at constant volume. Okay, previous class रे हम discussion करा है. So if P v to the power gamma is constant, that is K, so what we can write, P is equals to K by v to the power gamma. Okay, bas. So let the process changes from P1 V1 T1 to P2 V2 T2 ହେଲା दे जानि पालो तो adiabatic process equation लिखा होला then P value के K by v to the power gamma. Let the process changes from P1 V1 T1 to P2 V2 T2. So सेमती previous जेमती derivation start होउतला सेमती हबो. So then thus small work done will be how much? Small work done is equals to will be dw is equals to how much? Pdv. Okay, and thus total work done is equals to how much? So total work done is equals to w, that is equal to integration dw integration pdv. एठु मु केमती कैलकुलेशन करछि ताको भल से टिके जज करो. ओके, सो दैट तुम जानि परिबो. कॉपी मेंटेन करथाओ इमीडिएटली. So instead of pressure we can write what? K by, instead of pressure we can write K by v to the power gamma. So this is equals to integration K by v to the power gamma dv. Okay, v1 to v2, because volume changes from v1 to v2. Then K is constant, take it outside. K is constant, take it outside. Then next thing will be dv by v to the power gamma integration v1 to v2. अच्छा 1 by v to the power gamma को हमें कौन लिख परिबा? v to the power minus gamma. So we can write it as K into v to the power minus gamma into dv integration v1 to v2. Okay, so we know x to the power n dx integration is how much? X to the power n plus 1 by n plus 1 plus c. Okay, indefinite integral. Definite integral means integration limit add हेतिबो. So v to the power minus gamma dv integration v1 to v2 तब हमें कौन लिखिबा? K into v to the power minus gamma plus 1 divided by minus gamma plus 1 and your limit point v1 to v2. I hope it is clear to all of you. Then कौन पकाबो को? Then देखो constant की एठी minus gamma plus 1 by minus gamma plus 1, take it outside. So outside को आसला K by minus gamma plus 1 आउ ब्रैकेट रे केते रहला को v to the power minus gamma plus 1 लिमिट पॉइंट रहबा हमरो v1 to v2. थरे प्रैक्टिस कर देले मस्त लागिबो. सो केते आसीबो को नेक्स्ट v जगह केते पुट करबा अपर लिमिट देन माइनस लोअर लिमिट करबा. सो आवर इक्वेशन विल बी केते इक्वेशन विल बी. अच्छा आ गोटे जिंस या को हम कोन करबा देखो लिखुची स्टेप बाय स्टेप लिखुची. सो केते लिखबी k by minus gamma plus 1 लेंथी लागिबो तमे लिखि देला पर स्टेप ओमिट कर परिबो. ओके, सो अपर लिमिट पुट करले केते हो v2 minus gamma plus 1 minus v1 minus gamma plus 1. यस, नेक्स्ट कोन करबा को ए k जो कांस्टेंट ना ताको भितर को लिखबा. ओके, भितर को ताऊ नबा मल्टीप्लाई करबा तो रहला केते ब्रैकेट रे हमर रहबो सॉरी बाहर रहबा हमर 1 by minus gamma plus 1. अब ब्रैकेट भितर को केते गला फर्स्ट इज योर k v2 minus gamma plus 1 minus k v1 minus gamma plus 1. Okay, k v2 to the power minus gamma plus 1 minus k v1 to the power minus gamma plus 1. Yes, it भल से ऑब्जर्व कर मु केमती कोन प्रोसेस चेंज करछि. ओके, दैट पार्ट इज कंप्लीटली इंपोर्टेंट फॉर यू. ओके, सो आमे बर्तन कोन करबा k रो वैल्यू लिखबा. केमती लिखबा देखो प्रीवियस स्टार्टिंग पार्ट रो हमें पढिचे कोन k is equals to एट लिखिचे देखो हमें k is equal to how much? K is equals to p v to the power gamma. So ए k को हमें केमती लिखि परिबा देखो केमती चेंज करा होची. दिस k can be written k is equal to p v to the power gamma. So हमें लिखि परिबा k is equal to मु कोन लिखि प्रेशर p1 लिखि परिबी केमती लिखि p1 v1 to the power gamma भी लिखि परिबी और k is equal to हम लिखि परिबा p2 v2 to the power gamma. So corresponding pressure temperature हमें सॉरी corresponding pressure volume नै लिखा हबो. तो जो प्रेशर अच्छी P1 वॉल्यूम अच्छी V1 से टाइम रे k रो वैल्यू केते हो P1 V1 टू द पावर गामा. व्हेन प्रेशर इज P2 वॉल्यूम इज V2 सो k इज इक्वल टू P2 V2 टू द पावर गामा. सो एती खाली चेंज करियार अछि. सो कोन करिया देखो. सो नेक्स्ट थिंग इज 1 by minus gamma plus 1 हम लास्ट को आसे लेनी व्यस्त नहीं. सो देन ब्रैकेट इंस्टेड ऑफ दिस k ये लिखा है V2 K इंटू V2 टू द पावर माइनस गामा प्लस 1 सो आम कौन लिखा K भैल्यूटा को ट्रिक अप्लाई करो सो इट कैन बी रिटन P2 V2 टू द पावर गामा इंटू तुम रिमेनिंग के अच्छी V2 टू द पावर माइनस गामा प्लस 1 देन माइनस सेकेंड जो केस लिखा है देखो K V1 टू द पावर माइनस गामा प्लस 1 ये के जगह आम कौन लिखा P1 V1 टू द पावर गामा देन अब जहाँ से लिखा के V1 माइनस गामा प्लस 1 ओके नाउ इट इज क्लियर टू ऑल ऑफ यू एबे तुम पे इजी होगला बर्तमान आम कौन करवा ये कौन करवा देख V2 टू द पावर गामा अच्छी ये V2 टू द पावर माइनस गामा प्लस 1 सो पावर कौन हो बेस सेम अच्छी मीन्स पावर आड हो सेमती V1 पावर गामा V इंटू V1 पावर माइनस गामा प्लस 1 सो वी कैन राइट इट एज 1 बाय माइनस गामा प्लस 1 ब्रैकेट के P2 V2 टू द पावर के माइनस गामा 0 और 1 सो V2 माइनस P1 इंटू V1 yes okay up to this clear so we know equation of state is what PV is equals to nRT so आमर जो प्रेशर अच्छी P1 वॉल्यूम अच्छी V1 से टाइम टेम्परेचर के T1 so nRT1 so P1 V1 can be written like this also when pressure is P2 volume is V2 so your temperature is T2 so एतिक आम चेंज करिया देखो बर्तमान ओके तो फाइनल आंसर केते आसीबो so 1 by minus gamma plus 1 instead of P2 V2 we can write nRT2 minus instead of P1 V1 nRT1 हैला तापर इजी लिखबो nr टेक कॉमन nr so nr by minus gamma plus 1 ओके आरो लागेते T2 minus T1 बर्तमान मु छोटो जिनस चेंज करिया कहूची कोन जब हम एठी लिखि परिबा इट कैन बी रिटन nr by what gamma minus 1 ओके भीतर केते हिजबो दिस विल बिकम T1 minus T2 कोन कॉली मु जानि पहले तो ए T2 minus T1 रु माइनस साइन कॉमन नेली माइनस साइन कॉमन आनी कि बर्तमान कोन कली डिनोमिनेटर लिखा है माइनस गामा प्लस 1 से मल्टीप्लाई कली ओके सो माइनस कॉमन आनले दिस विल बिकम T1 minus T2 आ माइनस जो कॉमन आनले हम ताकू मल्टीप्लाई करिया -1 माइनस गामा प्लस 1 रे सेटा केते हिजबो गामा -1 सो दिस इज आवर आंसर ओके सो ऑल ऑफ यू रिमेंबर thus W is equals to how much nr by gamma minus 1 into T1 minus T2 okay this is the work done during which process adiabatic process so take the screenshot first तो देखिए गोटे लेंथी देखा होची किछि लेंथी नो लास्ट टाइम सिखिबा पड़ियो तुमको so work done during adiabatic process because of this reason एटा हमर बेस्ट 3 मार्क्स क्वेश्चन रे आसीबो ओके लॉन्ग क्वेश्चन आसले ता करेस्पोंडिंग गोटे न्यूमेरिकल भी थिबो सो हम क्वेश्चन डिस्कशन करिया नेक्स्ट लेक्चर रे so work done during adiabatic process so take the screenshot okay so what is CV molar specific heat at constant volume okay this page is clear okay next take the screenshot of this page small work done will be this one next is your take this screenshot okay next one is this and your last part is this one okay this is your last part so this is all about your what work done during different thermodynamic processes yes so एठी मु आ गोटे क्वेश्चन तुमको डिस्कशन करिया चाहूची ओके से क्वेश्चन हमर रिलेटेड अछि कोन स्लोप ऑफ डिफरेंट thermodynamic processes okay in next class we will discuss regarding slope of different thermodynamic processes so this is all about for today's class thank you have a nice day okay so stay tuned for next update